This is our math video project starring me, Sam G, Sam Q, and Eleanor. We're doing the limit theorems.
This is the sum of two functions.
The limit as x approaches c of f of x plus g of x equals the limit of x approaches c of f of x plus limit of g of x as x approaches c.
Oh.
Here is the product of two functions.
Here we have limit of x approaches c equals f of x times g of x, and that equals limit of f of x as x approaches c times limit of g of x as x approaches c. This is the quotient of two functions.
The limit as x approaches c of f of x over g of x equals the limit as x approaches c of f of x over the limit as x approaches c of g of x.
The identity function is that the limit as x approaches c equals c, and the constant function is that the limit k equals k when x approaches c. I'll look for some clues as to how we solve this problem. I found a clue! It says, sum of two functions. We need to use the sum of two functions.
Wait, I know how to do that. You end up with the limit as x approaches -1 x squared plus the limit as x approaches -1 of 3x plus the limit as x approaches -1 of -6.
Interesting. I should go look for more clues. I see one. Oh wow, this is a complex clue. There are 3 steps. First, we have to do the product of two functions, then constant times function, and then constant function.
Here I do the product of two functions, limit of x times x as x approaches -1.
Then you use the constant times function to get 3 times the limit as x approaches -1.
And then you do the constant function, -6. Let's go look for our last clue. I found it! This is an identity function.
Using the identity function, we get -1 times -1 plus 3 times -1 minus 6, which gives us -8. QED!
Okay, what did you learn from this?
This project really bettered my understanding of how you have to break down the problems into a lot of different steps. That's how you solve limit proofs. This also was a great refresher since we haven't done this material in a while.
Why did you choose this area content?
Well, we thought we already understood limit proofs pretty well and the limit theorems pretty well, but we wanted to better our understanding of it. Also, we wanted to use a cool and fun detective